Now I have a joint PDF and I want to find the constant c over the variable c and also the marginal PDF. So first, we know the property that the PDF, if I integrate the PDF, I will get 1. So that means x and y are from 0 to 1. It's joint PDF. So now we don't know if x and y are independent. Maybe yes or maybe not, but we need to find it out. So x is from 0 to 1, y is from 0 to 1, x plus y, dx dy. And then this equals 1. It is easily integration, so I save the time and tell you that c equals 1. So since c equals 1, I can find the marginal PDF of x. So marginal PDF of x, I just integrate the joint PDF of xy and take the integration y out. So it's here. X is x plus 1/2. And similarly, you can find the marginal PDF of y is also like y plus 1/2. And the expectation of y. Expectation of y, it's the all possible outcomes times the weighting. The weighting is the PDF of y. Here we have 0 to 1, y times 1 plus 1/2 dy. And you'll get 7 divided by 12. Now find the conditional PDF. Conditional PDF, y given x is the joint PDF divided by PDF of x. So it's x plus y divided by x plus 1/2. And now we want to find the probability. So the probability of y is greater than x given x is greater than 1/2. Conditional probability, so you know, like from the first class, it's the probability of x is greater than y is greater than x intersect x is greater than 1/2 divided by x is greater than 1/2. So from the numerator, it is actually the probability of x is greater than 1/2 less than y. And then denominator actually is 1 minus the CDF of x, 1/2. So this one now, it's a probability of like xy something here. So that means that's the CDF of x, y less than, it's a CDF of xy. So first, for the denominator, you have easily to have this form. From the numerator, it's a CDF of xy. So CDF of xy is x plus y dx dy. Now we need to find the upper limit and lower limit. From x is 1/2 to y. Absolutely. For y actually from 0 to 1, and it's from 1/2 to 1, correct? Because y is greater than 1/2. So after you have this, then you can find the answer is 3/10. Next one, find the conditional expectation. The conditional expectation again, the expectation, so you have those things, and actually it's y here. So for continuous integration, all possible outcomes of the random variable y, given the weighting, now the weighting is a conditional PDF. dy. As you can expect, finally this answer will be a function of x, because the expected y, I will integrate y out. So finally we'll have x. So it's not a number, it's a function of x now. So it's from 0 to 1, y times x plus y, x plus 1/2 dy. Then you can integrate this and you get the answer is x divided by 2 plus 1/3, x plus half. Next question, find the double expectation. This one, inside this, you'll get from part D, you know, that will be a function of x. So in this expectation, inside this expectation, here will be a function of x. So it should be x. So if we want to take this expectation out first, so I consider all possible outcomes of here. Times the weighting, because we know this is a function of x, so the weighting is a PDF of x. And this one you just get it from part D. Then you plug in and times the PDF of x. You can easily find the answer is still 70/12.